Okay, so in this video, we'll take another look at some aspects of IP addressing. And this is from chapter 6, and we are looking at configuring IPv4 addresses. So often we have a need for configuring multiple IP addresses for one LAN station. And Windows operating systems, the newer ones, do allow assigning multiple IP addresses to a single LAN station, and that's usually done via the advanced TCP/IP settings dialog box. And you can just about any newer version of Windows will have this dialog box. So you have one LAN connection, but you have multiple IP addresses. And the reason for doing this would be if the computer is hosting a service that must be accessed by different addresses. So externally, outside your server, there may be people in two different networks accessing that one machine. This can also happen if the computer is connected to a physical network that hosts multiple IP networks. That is possible. These are things that we rarely come across, but every once in a while you have to do this, and just it's good to know that this is possible. So configuring the default gateways will become an issue. And the default gateways are pretty much almost always used in IP configurations. So the only exception would be if you have a network where you never need to leave the network. So you're strictly in local area network mode. In that case, yeah, you don't need a default gateway. But if you look at networks overall, pretty much everybody is going to want to somehow leave the network, and you need a default gateway anytime you're going to be talking to an external network. So definitely if you're using the internet, yeah, you have to have a default gateway pretty much. So the default gateway's IP address must be in the same network subnet as the host's network ID. So that's always a rule. And just as you can configure multiple IP addresses for a LAN station, you can also configure multiple gateways, and that's not uncommon, although pretty much everything that we will do in the lab, in most situations there's just one default gateway, but it's good to know that you can have multiple gateways in a network. So Windows will automatically choose the gateway with the best metric. And so what is that? The metric is just means a way to measure something, and the metric that Windows uses is the time, or this, you could also say the speed. How quickly can you access the gateway? If a particular gateway is slow, then Windows will switch to something faster. And so when we say the word metric, just means how do you measure something. And usually for looking at a network connection, the metric is speed or time. How fast can you transmit data, or how quickly does a gateway respond? So here's an example. We have two computers. Computer 1 has the IP address 172.19.44.211. Its mask is 255.255.255.0. And the gateway, notice that it is in the same subnet as computer 1. So it starts with 172.19.44 because the mask is 255.255.255. And if you look at the very end, the host ID part of the gateway is 250, and if you look up here, 250 turns out to be the interface of the router that's connected to this network. So the mask is 255.255.255.0, just like here. And the IP address is 172.19.44.250. That's the IP address of this router interface. So remember that every router interface will have an IP address, and a subnet mask. And in this case, it has to match all of this router interface has to match, that is, the network ID has to match all the computers in that network. Similarly, on this side, you have computer 2 with an IP address 172.19.46.188, and the mask is once again 255.255.255.0, and it says here the default gateway or gateway is 172.19.46.250. So it's the third octet is different from computer 1, and the subnet matches the network ID of computer 2. And if you look up here, the gateway IP address corresponds to the IP address of this other side of the router interface pointing towards this local area network. Okay, so make sure these IP addresses make sense. The masks are, in this case, easy. It's all uniform. It's all 255.255.255.0. Okay, so another thing you can do is you can have a server with quote-unquote 2 homes and 2 or more homes. A multi-homed server has at least 1 NIC, and usually 2. It can have more. So that's basically 2 or more network interface cards, each attached to a different IP network. So this diagram is sort of like very different from ones we've seen in the past, in that usually you have a router and one side will look at a network, the other side will look at a network, and so in that way it is very similar. But then you have 2 of these. So here once again you have a router here, a network with a private IP address 172.16.200.207, net private IP addresses, class B. And then on the other side you have a switch with a totally different network 172.16.208, and then here in CIDR notation we have .0/24, which means the subnet is 255.255.255 essentially. Okay, so if you just look at this router, you have a network on this side, a network on this side. There's nothing amazing about that. But then if you look at what one of the machines connected to this switch is doing, it's got a certain set of IP addresses on one side and another set of IP address class. In this case, it just happens to be a class C private IP address 192.168.1.0/24. And so what this is indicating is that you have 2 network interface cards and they're connected to different switches, which means different LANs. So these are 2 different LANs, and this computer can talk to both of them. So we don't often see that, but if you remember from the lab, all of our servers have 2 network interface cards, and so they're all capable of doing this. But typically it's not common to make servers multi-homed. You can do it, and you can actually even have this server act as a router. You can have routing capabilities in pretty much any computer. Servers can do it. You just have to turn on the routing facilities, and it's not common to do that because you have routers usually to do routing. But you can make any Windows 10, Windows Server, the newer ones, you can make them do some of the same things that routers do. Okay, so each NIC requires its own IP address for the network to which it's connected. So why would you want to use multi-home servers? For various reasons. You might say that you might have a situation where a server is accessed by internal clients and external clients. That might be a possibility, and you're talking to both sides. Server provides maybe resources for computers on multiple subnets of a network. So you might have divided up a network into subnets, and you might have a server talking to people to 2 different subnets. Or you can configure a server as a router or a VPN, virtual private network server. And so there, what you would be doing is protecting traffic, or maybe just using a different subnet or network. So these are things that these are good reasons for using this kind of configuration. And there's many situations where you do this, but often, for example, for VPNs, you might have hardware specifically for VPNs, and it'll end up looking just like a multi-home server. You might have hardware specifically for firewalls, and firewalls look like a multi-home server. So there's a lot of reasons why you might want to do this kind of thing. One thing to watch out for is that multi-home servers can run into routing issues because you have to configure multiple gateways, multiple default gateways. So that would be a concern if you use multi-home servers. So Windows computers do maintain a route table or routing table, and what that tells you is where any packet should be sent based on the packet's destination address. So we'll see more of this when we get to routing, and when we look inside the settings of a single router, and you see the same kind of information. You'll see a routing table. You can open up a Windows command prompt and type in route space print, hit return, and you can see the routing table, and there'll be 5 columns. Of course, the way to think about it is, where is a particular packet going? That is, what is the network destination? And then that's what the routing table tells you. You have to find a matching network destination for every packet that you're sending out. So you'll have these 5 columns telling you where any given packet that comes in on an interface should go. So the network destination can be a single IP address, but more often it is a group of IP addresses. And so these describe network segments that the computer is attached to. You'll also have a net mask. Usually it's something with 255 somewhere, or some other, or maybe a more complicated network mask as well. You will have a gateway that this packet will be sent to, and quite often this is the default gateway in most computers that are on a single LAN. The gateway is either saying that this computer will handle it, and then that would be called on link, and then or else you have the IP address of the default gateway for that network to which a packet will be sent. You'll also have an interface which tells you which interface the packet is coming in on, and so sometimes you do have multiple interfaces, in which case there'll be multiple entries corresponding to the interface. And you have a metric which basically measures how much delay there would be in talking to any external router. So not only can you see the routing table by saying route space print, but you can also use the route command to change the routing tables and do things like fix issues caused by using a multi-home server. So you can have a server even act as a router, or you can fix issues. Even if you're not routing, you're going to have things coming in on 2 different network interface cards, and so you might be misconfigured, and so you can use this route command to change the routing table and fix things. There are other IP configuration command line tools. So if you open up a command prompt, and you might for some of these commands to change things, you might actually have to open it up and run it as an administrator. So coming back to this, for route print, probably you don't need to run as administrator, but if you want to do things like change the routing table, then you would have to open up a command prompt as an administrator and then use the route command and then change the routing table. Then that would become possible. So there are other commands that also require you to run the command prompt as an administrator. So there's net shell, ipconfig, which chances are you've used, ping to check for connectivity, ARP to look at the ARP cache, traceroute to figure out how a packet gets to its destination, and then NS lookup or name system lookup to look at domain name service settings, or look at DNS for a particular IP for a particular name. So there are additional tools besides these, and these are usually generally good enough to correct most IP configuration settings and connectivity. So here's an example of the use of netshell. So this is on a Windows system. You type in netshell at the command prompt, and sometimes you might need to, if you need to make changes, you will probably need to run the command prompt as an administrator, which means you have to have the administrator password. Okay, so the thing to note about this is netshell. When you run it, it'll give you a prompt. So this is something that netshell prints, and then you can type in other commands. And so I believe you can say netshell space \, to see all the options. And you will see this kind of commands later on when we look at routing and we look inside, sort of inside the router. You'll see the same kind of setup. You type in a command, you get a prompt, you type in more commands. Like in this case, we say we want to look at the interface, the IP interface, and then you get another prompt. So this netshell.exe command allows you to use things interactively, and these are contexts inside netshell.exe. So you have the netshell context, and you type in a command, you enter another context, IPv4 interface, and then you can do things like this. So try it out. Just open up a command prompt and type in netshell, and netsh, and then it'll give you a prompt. Type in interface IP, you type, and it'll give you a different prompt for a different context that you're executing in, and then you type in show config. So that's a different command. So every context will have a different set of commands, and we can have different kinds of outputs that you generate. So a common one is you'll get configuration for Ethernet, or it might be Wi-Fi. It'll tell you things like whether DHCP is enabled, what is the IP address for that interface, subnet mask, or the CIDR notation. You can find out the default gateway, metric, how close is this gateway, and how fast is this interface, things like that. What is the DNS server connected to this interface, and other things. So wins that you don't have to worry about. Okay, so one thing I want to note is that anytime you use a computer, you will have a loopback interface, which is actually a pseudo interface, which means it is not actually a physical network connection. It's actually in software. What it says is that essentially anything that starts with a 127 dot pretty much anything, and you can see that here, 127.0.0.0/8, which means only the first 8 bits are in the subnet mask. And so we have a network where only the first octet is defined to be fixed, actually, and all the other 3 are free to vary, and you actually have all of these for your computer, your own computer. And so there's a whole lot of addresses that are assigned to your computer, and this is used to usually test out all kinds of different networking problems within a computer. So there's no DNS configured, there's no DHCP for 127 dot anything. Okay, and these are loopback interfaces. Most of the time you want to ignore this because you're just saying this is a network connection to yourself. It's usually done to check settings, to do things like test your internal network setup, things like that. Okay, so you just want to be aware that anything that starts with the 127, so 127 dot anything, on those are all local addresses. Okay, so we looked at how the interface IP context of NetShell. There are also things for DHCP, for LAN, for NetIO, HTTP, and firewall, all to debug your networking settings. And so here are a couple of examples. If you want to configure, that is, change the IP address of your machine you're using the Ethernet, this is what you would type in NetShell, and then you can hit return or just type in the entire thing, interface IPv4, and then here's the command. You're setting the address for Ethernet, for the Ethernet interface, to a static IP address of 10.1.1.1 with a subnet mask of 255.255.0.0. Okay, here's another command you can use, and you can type it all in one line: NetShell interface IPv4, and then here's the command: set DNS for Ethernet to be the static IP address 10.1.1.100, and make that the primary DNS server for this interface. You can also have a secondary or alternate. Okay, chances are you've used ipconfig already, and it's usually used to display the computer's IP settings, and also do things like change DNS settings and DHCP settings. And so there are various options for doing that. You say ipconfig /all, and this is the / all, or you can say release my my settings, especially DHCP settings. You can say ipconfig /release, so you don't need to type in this, or you shouldn't type in this hyphen. It's ipconfig /renew, and so on. And chances are you will use it, or you have used display DNS, flush DNS, and register DNS in the lab. Okay, so let's stop here and pick up again with the ping command in the next video.